Thank you very much, David, and thank you for the invitation to speak today. Now, we've heard this morning quite a lot about the political, the economic and some of the social drivers, the constraints and opportunities around the current situation. What I want to talk about now is some of the technologies that I think are a very important part of the future. Now, don't panic because I've mentioned the word technology. I'm going to take you through slowly and I've got lots of pictures. But I think it is quite important if we're going to look at the future to see the future role of technology. We've heard about the opportunity to do something different, spend less and get more value, and using technology is a way to do this. So in order to look at future-proofing the asset, we've got to know something about the future. And I guess without thinking too hard, we do know quite a lot about it. Moving people and goods is going to remain very important to us, very strong link with the economic growth. Doing that means we need to have a good condition network, and that means we need to maintain it. But the available money for maintenance is going to be limited. These are very real economic constraints we have at the moment we're all facing. What we haven't heard so much about today, and I'm going to bring in a bit, is the environmental aspects, both from the point of view of valuable resources and the need to recycle, and also the fact that the assets need to be robust to the more extreme weather events we can expect in the future. So I'm going to talk in kind of 4 sections today. First of all, about determining the condition of the asset, then how we use that information to make decisions, then some of the established and newer maintenance options, which are very promising, and how we make those decisions, and then at the end, just before lunch, when we're all feeling a bit lightheaded, a bit of future visioning. So why do we need to determine the condition? I was so delighted to hear Stephen talk passionately about the need for better condition monitoring. Well, the first thing is we have a very valuable set of assets that we're charged with looking after. These are the figures actually for England, but very significant figures. And then the annual maintenance spends are here. Stephen also spoke about the benefits of proactive maintenance rather than reactive. And surveys have suggested that last year something like 25% of these budgets were spent on reactive maintenance, i.e. sorting out problems that potentially more proactive maintenance could have avoided. And for those of you playing pothole bingo, I am going to mention potholes because they're the most widespread perhaps manifestation of some of this. So in order to ensure that our maintenance is properly targeted and we're doing as much proactive stuff as possible, we need to know the condition of the network, and we need to know that accurately, and we need to collect that data very efficiently. We also then need to know about how the asset actually deteriorates and the physical mechanisms in order to actually predict where the maintenance is needed. I'm not going to talk about that piece today, that's a whole other subject, but I am going to talk about how we collect data about the condition and talk about some of the future developments. First of all, looking at surface condition, the Harris system, TRL has worked on this for the Highways Agency over a number of years, and a lot of this technology is now used very widely across the whole network. So things like the laser systems and the photo collection look at longitudinal and horizontal profiles and look for cracking as well. The benefits of this sort of system are that they can be driven at traffic speed, there's limited disruption to the traffic, you don't have to close the road, you can collect a lot of good data very quickly, very accurately. We're doing further work at the moment looking to see what else we can look at as part of these surveys. And one example is looking at ground penetrating radar. So as well as looking at the surface, we're actually collecting information about the asset and the structure of it. In particular, looking at things like consistency of construction and voiding. Sticking with the structure, this is a newer innovation, the traffic speed deflectometer, try and get that out, TSD, which measures the structural condition of the pavement. Previously, these structural surveys were done at walking speed, pretty much walking speed, and involved closing various lanes of the highway. What this system does, it's got lasers, it measures the acceleration of the pavement surface as the articulated lorry drives over it, from which we can derive information about the structural condition of the asset. This was originally a Danish innovation. We've done work for the Highways Agency in developing that system further to the point at which it is now used on the network and is providing valuable information. Let me move for a second to other assets and bridges. Again, this is an established technique now for measuring the condition of post-tension steel bridges, where there's a potential failure by corrosion and a fracture of the wire strands within the concrete structure. This is an acoustic technique that basically listens for breaks in the post-tensioned wires. This particular technique has been used for 14 years on one major structure in the UK, and what it's avoided is unnecessary or premature strengthening by taking that data and understanding the condition of the asset. Sticking with bridges for a moment, most bridges are inspected visually, and at TRL now we're developing some techniques to automate the inspection using digital photography and image analysis. The benefits of this sort of system are you can collect a lot more data more accurately and quicker, but also it's a much more objective and repeatable survey where you can compare the condition of a structure between surveys using these analysis techniques. This one is pretty much in the development stage. Another technique for looking at the condition of assets is in the glamorous area of drains, which we all know are very important on highway structures. And this can't really claim it's a terribly high-tech solution, but on the top photo, what we have is a speaker and microphones inside an inflatable ring, which basically is lowered into a drain system. By firing an acoustic pulse and seeing if there's any reflection back, what this research program is looking at is whether we can gain information about the state of blockage of the drain. This is showing some initial promise, and it's just going to the development stage of trials. But again, the benefits of using this sort of technique are about improving the speed of collection of data and ultimately reducing the cost as well. These surveys are quite expensive at the moment. Let's move on now to a last example, which is about the road being more intelligent. So instead of us going out and scanning over something and measuring something, how about if we can actually get the road to talk to us? So the first example there, those little tap washer, things that look like tap washers, are radio frequency ID tags onto which you can imprint information that can be read by electronic scanners. These are showing very good potential for gaining information about the condition of the road. Initially, they've been used more as kind of labelling devices, so you can imprint onto them precise information about the structure of the road and the mix, and basically throw them into the construction and then read them afterwards on machines like Harris by putting a scanner onto Harris. Going further than that, though, we're looking at putting accelerometers onto these MEMS devices to see if we can get an in-situ measurement of the structural strengths of the pavement, and that information can be broadcast directly to us. Going on from that, we're looking at energy harvesting and powering of these devices from the road, and situations where the device could actually tell us information about the temperature of the road, which would then again help with winter maintenance. So these are a bit more at the development stage, but they are showing, as I say, good promise for the future. So I now want to move on to the second part, which is really about, okay, so we're getting very good at getting data more effectively, more accurately. What do we do with it? And really, the benefits of this are it helps us make better decisions about potential maintenance sites and then what maintenance is necessary. Now, there are a whole bunch of factors that come into the decision-making here, and the decisions are generally made in very structural frameworks like value management type approaches. And particularly where you do the maintenance, and that those decisions can be made at a scheme level or a local network or a national network. And the balance of factors can change over time as well. What I really wanted to concentrate today is not so much the decision-making on where maintenance should be done, but the decision-making on what particular maintenance technique. Again, I can talk for hours on the other one, but I'm going to talk about the maintenance techniques. So, for example, with the where, you would consider factors like safety and the accident propensity of a particular location. The big one, though, is costs, and this is going to be a big factor in the decision-making that will be with us for some time. And in particular, the balance of the initial cost and the desire to lower that now against the whole cost. What we do must clearly be affordable in the short term, but if we take the cheapest solution in the short term, we've heard it this morning already, it just isn't going to provide the best value. And there they are, there's the potholes. They are relatively expensive to fill, estimates of 20 times the unit cost of normal asphalt lay, and the repair can be short-lived if it's not done well. So cost is right up there on the decision-making.